All right, today we're going to get down to brass tacks. We're talking about a calculation where you absolutely have to be right every single time. We're going old school pen and paper to figure out one of the most critical safety checks there is, calculating the total load of a scaffold.
And let's not mince words here. In the world of scaffolding, one tiny mistake, just one little miscalculation, well, it can be absolutely catastrophic. The stakes are as high as they get.
That's right. A mistake here isn't just about money. It can cost lives. You know, the real foundation of scaffold safety isn't the steel itself. It's knowing exactly how much weight that steel has to hold up.
Okay, so let's dive right in. If you want to know for sure if a scaffold is going to hold strong or if it's at risk of collapsing, there's one thing you have to do. No exceptions. You must calculate its total design load. This isn't guesswork. It's simple, crucial math.
Now, I know what you're thinking. Calculation sounds complicated, but really, the solution is beautifully simple. Let's just call it the golden equation for safety. It's really the hero of our story today. So what is this total load? It's really just the combined weight of two things. First, you've got the weight of the scaffold itself. We call that the dead load. And second, you have everything you're going to pile on it while you work. Workers, materials, tools. And that's what we call the live load. Simple as that.
And here's the golden equation, right here. Step 1, figure out the dead load, the weight of the scaffold just sitting there. Step 2, add the live load, the weight of everything you're putting on it. Dead plus live equals your total load. That's it.
Okay, theory is nice, but let's make this real. We're going to walk through a super simple, practical calculation. I really want you to see just how easy and absolutely essential this is. You don't need any fancy software, just some basic math.
So let's picture this. We're dealing with a pretty standard medium-duty scaffold platform. For example, let's say it's a simple 2 meters by 2 meters. Nice and easy.
So a 2x2 platform means we have a total working area of, you guessed it, 4 square meters. Now, this number, 4 square meters, this is the key. It's the foundation for our entire calculation, so burn it into your memory.
All right, let's get started. First up, we need to calculate the dead load. Remember, this is just the weight of all the parts, the pipes, the boards, the couplers, the whole structure itself, just sitting there. So, how do we get that number? Well, a typical medium-duty scaffold structure weighs about 40 kilograms per square meter. That's a pretty standard figure. So we take our 4 square meter platform and multiply it by that 40 kilo number. So what do we get?
Boom, 160 kilograms. That's the weight of the scaffold just sitting there completely empty. This is the number that so many people forget, but it's a huge piece of the puzzle.
Okay, we've got the weight of the structure. Now for part 2 of our equation, the live load. This is all about what the scaffold is actually designed to carry. You know, the people, the materials, the equipment. So the key here is the rating. We said it was a medium-duty scaffold, right? Well, by standard classifications, that means it's rated to hold 225 kilograms for every square meter. So just like before, we take our 4 square meter area and multiply it by 225. And that gives us a live load capacity of 900 kilograms. That's the absolute max weight of people and stuff we can safely put on this platform. Now, for the moment of truth, we take our two results and we plug them into our golden equation. The total load equals our 160 kilogram dead load plus our 900 kilogram live load, which gives us a grand total of 1,060 kilograms. That is the true, honest-to-goodness weight that the scaffold's foundation and its support posts have to be able to handle. And I want you to just let that sink in for a second. 1,060 kilograms. That means the standards, the vertical poles, and the whole platform have to support over 1 ton. That's the weight of a small car. All of a sudden, that little 2x2 platform feels a lot more serious, doesn't it? So we did the math, great, but now for the million-dollar question. Why is this calculation so absolutely essential? I mean, why can't you just kind of eyeball it and call it a day? Well, let's think about the single most common mistake people make. What happens if you forget about the dead load? What if you only think about the 900 kilos of stuff you're putting on it? The answer is simple, and it's incredibly dangerous. You've completely ignored 160 kilograms of weight. The supports, the foundation, they are all under a hidden strain from the weight of the scaffold itself, a strain that you haven't planned for.
And that's how disasters happen. And it's not just about how much weight, but how you place it. Piling all your weight in one spot, like a single pallet of bricks, creates a really dangerous point load. It's always safer to spread that weight out evenly across the platform in what we call a distributed load. Okay, as we start to wrap this up, let's lock in the key lessons here with one final crucial tip for safety, because really, that's what this is all about. So please remember these rules. First, that total load, our 1,060 kilos, has to be distributed evenly across all the scaffold's vertical support posts, the standards. Second, and this is non-negotiable, you have to use a 4-to-1 safety factor. This just means that any single support post should never carry more than 25% of what it's technically capable of holding. That extra 75% isn't wasted space. It's your safety net. It's what saves you when something unexpected happens.
So what's the big takeaway from all this? It's simple. Do the 2 minutes of math before you even start to build. Grab a pen and paper, use a basic spreadsheet, whatever works. Because when you're dealing with over a ton of weight hanging in the air, gravity doesn't give you a second chance. Safety is simply irreplaceable. So the only question left is, are you going to take the time to do the math?